So let's talk about mapping the wind and try to describe where it is and where it is not windy in this country and why. First of all, here's what you need to do to earn your done stamp. You got to prove to me that you've learned something from this presentation. You do not have to write a paragraph or even a complete sentence. You don't even have to answer every one of these questions. What you do have to prove is that you have learned something. I will give you a done stamp on your paper for doing something. But remember, the key point here is learning. So it's got to get in your brain. It doesn't all necessarily have to be on your paper, but don't kid yourself. This is what I'm teaching you. This is what I want you or need you to understand about the wind. So first of all, some reviews. Wind is caused by a difference in pressure. Well, how do we get high and low pressure? Well, high pressure is caused by cold air sinking, and low pressure is caused by hot air rising. So here's a map of places where it is and is not windy in this country. Red is where you get the most wind, blue is where the least, and green is somewhere in the middle. And you can kind of see here, seems like we have a lot of wind in the middle part of the country. In addition, a couple places here along the coast. We got to explain why. Why is it so windy in the middle of our country? Well, remember what we learned about temperatures in this part of the country. They swing. They go from hot to cold very easily because they're so far away from the water. So you get the cold air, you get the hot air, you get high pressure, you get low pressure, and therefore you're going to have wind. So the number one reason why it is windy in the Midwest is the temperatures there change so easily because they're so far from water, and that's where you get the hot air masses coming up from the south, and they meet the cold air masses coming down from the north.
So here I'm standing in the Midwest part of the United States, more specifically in Nebraska. And this part of the country is where it tends to be windiest. And there's a couple reasons for that. First of all, look at the land behind me. It's almost impossibly flat with no mountains, certainly no large buildings or large amounts of trees to stop the wind. So once the wind gets going, there's nothing to break it up. Ergo, this area always tends to be windy because there's nothing to stop the wind. So how does that wind get here? The second reason why it is very windy here is because we're right in the middle of the country, way away from the ocean. So all of this land can get hot and get cold very easily. So remember that wind is caused by differences in pressure, which comes from differences in temperature. So if you're someplace where you can go hot and cold pretty dramatically, like here, far away from the ocean, you're going to get some different pressures and you're going to get some wind moving. Once that wind gets moving, as you can see, there is nothing to stop it back there, so the wind is always going to blow. So once again, in summary, the middle part of our country, the Midwest, is where it is windiest because it's very flat with nothing to block the wind, and there's always different temperatures that cause different pressures because we're so far away from the ocean.
So the first of our two big conclusions about where is it windiest in the United States, first of all, it is windy in the Midwest. That's what we call the middle part of our country.
So let's talk about places where it tends to be windy. First of all, remember that wind is caused by differences in pressure, which is caused by differences in temperature. So if you have one location that is hotter or colder than another, air is rising one place, sinking another, you're going to get differences in pressure, which is going to cause the air to move from high to low pressure. That's what wind is. Well, one of the places where it always tends to be windy is here along the coast, because that water out there is almost always going to have a different temperature than the land behind me. The sun comes out on a nice sunny day like today, and the land's going to get warm, and so the air over the land is going to rise because the air there is getting hot because the land is getting hot. That's going to lead to some low pressure. Well, out here the ocean doesn't change temperature that much, so over the ocean it's going to be a little bit cooler. Air is going to tend to be sinking, and you're going to have some high pressure. So almost always at the coast it is somewhat windy because you have different temperatures between the land and the water due to the fact that water doesn't heat up and cool down very easily. So once again, one of the places where it always tends to be windy is at the coast.
So now we understand that this is windy primarily in two areas in our country, the Midwest and the coast. Well, let's explain why. What causes it to be windy in those two areas specifically? First of all, unequal temperatures cause unequal pressures, which causes wind. So we understand that in the middle part of our country, we get a lot of unequal temperatures, hence unequal pressures, because that's where the cold and hot air masses tend to mix, and you're far away from the water. However, over here along the coast, the land here and the water are always going to have different temperatures. Hence, they're always going to have different pressures, and that's going to cause wind, which tends to make areas near the coast windy. That's the first reason. I do want to use this picture here for an example. This is Fairbanks, Alaska in the middle of wintertime, when all they have is cold air. And I mean really cold air. They have no warm air at all. So you're not going to get much difference in pressure, and hence you're not going to get much wind. And you'll notice this is steam coming from the engine of a semi-truck parked in really, really cold air. And you'll notice how vertically the steam is rising. There's absolutely no wind at all to move the steam away, because in Fairbanks, Alaska, it's dead calm. It's very still all winter because they don't have any hot air to make an unequal pressure with the cold air that they naturally have. Now, the second big reason why it is very windy in those places is that you have lack of what's called friction. Friction is a term that means things that get in the way of wind, whether it's trees or mountains specifically, or even big buildings, say in the middle of a city. If you don't have stuff that gets in the way of wind, the wind can get going and keep on going, picking up steam and get faster and faster because there's nothing to slow it down. So think about friction as things that act as like a speed bump to wind, that get in the way of wind and keep it from going too fast. These are all places where there's a lot of friction. There's buildings and mountains and trees that block the wind, and hence the wind is not going to be as strong in those areas. Friction is also the reason why windmills have to be raised off the ground to be effective. Down here, there's too much stuff that gets in the way of wind. So the wind hits something and bounces off, and it slows down or it dissipates. However, the higher up you go, there's less stuff in the way of wind, and hence less friction, and wind is going to blow faster. Is the other reason why smokestacks always have to be built high, as well as things like chimneys, because what you want is you want this smoke to be blown away by the wind. Well, if you didn't have a smokestack that would allow the smoke to get up there where the wind is blowing strong, you'd wind up with a bunch of smoke near the ground, which is what you don't want to have.
So take a look behind me here, and you'll see there's 3 windmills back there behind me. And the purpose of those windmills is to generate electricity. The wind blows and it turns the blades, which in turn spins a generator inside of it, which makes electricity. So we've got wind that is being used to produce electricity. Now where I'm at here, you can tell I'm not in Georgia. I'm in the Midwest. I'm in Kansas, where it is very, very flat and there's nothing to get in the way of the wind. So we pretty much all the time have a pretty good wind here blowing, which makes it a great location to put some windmills and make some electricity. Now, you won't see these in Georgia. Why not? The reason is, in Georgia, our wind doesn't blow strong enough or often enough. And even if it does get blowing, it's got too many things like trees and mountains in the way that stops the wind from blowing fast enough in order to make a windmill like this cost effective. So once again, if you know where the wind blows the most, you can put up windmills and have an efficient, free, or almost free generation of electricity, like they do here in the Midwest.
So it is not very windy here in Atlanta. The question is, why doesn't it tend not to be very windy? And there's actually 2 reasons. The first one has to do with temperatures, which we know cause the pressure. And so you need that mixture of high and low pressure, which comes from higher and lower temperatures. For the most part, what we get is this air mass here, this maritime tropical, which is pretty much warm air. So for the most part, we have warm air over us. And what we're missing is this guy here that comes and gives us an unequal pressure. So too much of the year we're warm, and we're missing that colder air that is needed to give us an unequal pressure and hence wind. Now, the second reason it doesn't tend to be windy here is we got a lot of mountains and we got a lot of trees that get in the way of wind and keep it from getting too strong. Now, when would you expect it to be windiest in our area? Because we do get some wind, we're just not overall a very windy location. We're only going to get wind when we get that mixing of hotter and colder air. So what we need is we need this guy, that continental polar, to come and get in the way of or start interacting with our maritime tropical. When would this happen? Well, it starts from about late fall, right about where we are now, to about the end of spring. Because once we get past the end of spring, all we've got is this guy here. So we're going to be windiest from late fall, when we start getting that cold air coming from Canada, hence that higher pressure, to about the end of spring. Now, the average wind speed for Atlanta versus Dodge City, Kansas. Notice that Dodge City, Kansas and Atlanta have somewhat similar latitudes, but notice the big difference. 50 miles per hour versus less than half. And that's because in this part of the country, they get more readily more often interaction between the hot and cold air, and hence high and low pressures. Plus it's flat and there's not much to get in the way of wind there. Mount Washington, New Hampshire is a very unique place in the study of wind, and it's very, very famous in the weather community for the longest time, and I think still to this day, the highest ever land wind speed, now not over the water, but over the land, the highest wind speed ever recorded on land was recorded here. And it was 231 miles an hour, and that's what it registered before the anemometer actually broke. Mount Washington is in a place where they get a lot of wind, and here's why. It's way up in New Hampshire, and so they tend to get that continental polar coming down from Canada. And they tend to get the maritime tropical air mass coming out of the Gulf of Mexico, gets carried up that way by the jet stream. In addition, you also have a fairly cold water current here. So you got a lot of crazy changes in temperature and a lot of different air masses meeting. Plus you're up in a mountain, you're kind of raised up above the ground around you. So all of these things lend to Mount Washington considered to be the windiest place in our country, and it's actually the place where the highest wind speed ever was recorded over land.
So this is one of the windiest places that I've ever experienced. I'm at the Cape of Good Hope, down at the very tip of Africa. And let's look at why it's so windy. You'll notice it's all water all the way around. It's a little spit of land that sticks all the way out in the ocean, so there's nothing to stop the wind. It just comes all the way across the ocean all the time, and hence it's very windy here.
So why so much wind there in the Cape of Good Hope? Well, you can see where it is on the map. And what happens is the southern part of our planet, the southern Arctic Ocean, you'll notice there's no land in here. There's a big stretch of the earth where the wind can just get going and going and going because there's nothing to stop it. Commonwealth Bay in Antarctica is considered to be the windiest place on the planet by some accounts. And you can see the reason why. Because once again, the wind gets going, the wind gets going, the wind gets going, and there's nothing to stop it, so it just keeps going. Now you might ask yourself, well, how can it be so windy down there if it's way down there near Antarctica where it's always cold? You got to remember, these are places on the water, so what happens is we know that the water can expand, especially here out of the Indian Ocean where the water is trapped and it cannot expand north, it expands south. So that's where the mixing of the hot and cold comes from to make the ocean around Antarctica so windy. You'll notice at the North Pole, you don't have that same effect because there's a lot of land that gets in the way of the wind getting going. So let's talk about wind and the waves, because the waves in the ocean are driven by the wind. All a wave is a piling up of water as the wind blows across the surface of that water.
So let's talk about wind and the waves that they produce. All waves are generated by the motion of air moving across the top of the water, which pushes the water that is at the surface. That's why you don't feel waves below the surface, because it's just wind blowing the water across the top. Well, in places like in California, they get really big, powerful waves like you can see back here behind me. The reason is twofold. One, the Pacific Ocean is very large, very deep, has a lot of water in it, tends to stay pretty cool. Well, the land can heat up and cool down pretty easy, especially in the sunlight. So you're going to get a greater difference in pressure and hence a stronger wind. The other important factor, and probably the bigger one, is the fact is that out that direction, the Pacific Ocean goes on for a couple of thousand miles. There's no landmass between here and Asia. So once the wind gets blowing this direction, there's nothing to get in its way. It doesn't hit any mountains, it doesn't hit any trees or buildings, there's nothing. So once the wind gets going, there's nothing to stop it, and hence you get really large waves on the west coast of the United States, like in California.
So not every body of water is going to be the same. So the waves in those bodies of water are not going to be the same. Specifically, let's look at the Pacific Ocean and the Gulf of Mexico. And let's talk about surfing, because surfing needs big waves. It's fun to ride down the big waves. In Florida, in the Gulf of Mexico, the water tends to be very calm. Doesn't tend to be very many big waves in Florida. Yet in Hawaii, you can get crazy big waves like this. And that's also true on the California, on the West Coast. Those are places where people go surfing because the waves are bigger. The question is why? Well, first of all, think about the Pacific, then the Gulf of Mexico. The Pacific has some cold water because it has a part that's way up north, and it has some hot water near the equator. And when those two meet, you get unequal temperatures, which causes unequal pressures, which causes wind. Well, the wind's going to blow the water, and there's a lot of water. There's a big area in the Pacific where the wind can get going and never have anything in its way, so you're going to get big waves. The Gulf of Mexico, on the other hand, is only hot water. It's missing the cold that it needs to make a high pressure to go with the low pressure, which would get that unevenness that would cause wind and hence waves. It is also a lot smaller body of water. If we think about wind, man, the wind here in the Pacific Ocean, it can get going for a long, long way. And the water can pile up into big waves because there's nothing to stop the wind. The Gulf of Mexico is really, really small. So it's hard for the wind, which they don't really have anyway, to pile up water into really big waves. So to summarize, Pacific's got hot and cold, which is going to give you more wind, and the Gulf of Mexico is just hot, missing the cold. Also, remember that the longer the wind blows, the further the wind can blow without hitting anything, it's going to make a bigger wave, a stronger wind. So the Pacific is big and the Gulf of Mexico is small. Now, these two terms are windward and leeward, and this is specifically talking about islands. The windward side of the island is where the wind is blowing from the water and it hits the land side of the island. On the other hand, the leeward side is the other side of the island where that wind has gone over the island and now is blowing out to the water. And there's a very distinct difference with islands from one side to the other that is caused by the wind and how the wind hits the island. Let's consider the island of Aruba. And it has a windward side and a leeward side. And you'll notice the size of the arrows. Even if Aruba got hit with wind equally on both sides, the wind on this side of Aruba is going to be stronger because the wind can blow all the way across the Atlantic Ocean with nothing getting in its way. On the other hand, if the wind was coming from the other direction, it cannot get going very, very far before it hits land. And that means the waves on that side of the island are going to be a lot smaller. You can actually see this. The windward side of Aruba, notice how the water is very dark and it's deep, and all these little white spots here, those are the white caps. Those are the big waves. So we get a lot of water moving on this side of the island. We get a lot of waves hitting this side of the island. On the other side, the leeward side, you'll notice it's very, very shallow. That's because the wind there can't make big waves on that side of the island. So the sand just kind of stays there. On the windward side of the island, where it's constantly getting hit by wind and waves, all the sand gets moved away.
So looking out there across that ocean, in a straight line from where I'm standing, thousands of miles away is Africa. And there's absolutely nothing between me, where I'm standing here in Aruba, and the continent of Africa. Well, that means there's also nothing to block the wind, because it's all ocean. So there's no trees, no mountains, no other land masses between here and Africa. So that means that those trade winds that are blowing from east to west, close to the equator here, have nothing to get in their way, which means there's almost nothing to stop them, and there's nothing to slow the winds down. So when the wind hits this island of Aruba, they're going exceptionally fast, and faster winds make bigger waves. You can see the waves here. The ocean's pretty choppy. I'm standing on the windward side of the island. This is the side of the island that the winds always blow towards. Now, because the winds blow always on this side of the island, and there's nothing to make the winds slow down, they generate pretty good waves and high surf action. And so that means on this side of the island we get a lot of weathering and erosion. This side of the island looks something like this. There's no beaches. All of this water just keeps hitting these cliffs and these rocks and chewing them up, taking away the rocks after they break them into smaller pieces, and you see what happens like there. Those are big chunks of the cliff that fell down once the waves eroded, weathered and eroded the part of the rock underneath. So this is what the leeward side of Aruba looks like, and you're going to notice a couple of things different right off the bat. First of all, there's nice pretty white sand on this side of the island, and that's because this side of the island is made up of mostly limestone, which is a nice white rock. So when it breaks down, it forms this nice pretty white sand. Now the other thing of note here is the nice wide sandy beaches, as opposed to the windward side where the waves are always crashing up against the land and the winds are always really strong onto the shore, and all the sand that does get made gets moved away. This side of the island, the breezes are a lot more gentle and they're moving out to sea. So the waves you can see on this side of the island aren't nearly as big or nearly as rough. So these waves can't take and remove the sand like they can on the other side of the island. So on this side, you get nice, wide, flat, sandy beaches. On the other side, you have rocky, jagged cliffs. And that's the difference between the windward side of an island and the leeward side. And that's generally the case in about any kind of island, whether it's in the Caribbean or Hawaii. You're going to notice a big difference between the windward side and the leeward side.
You notice the same difference between the sides of the island in Hawaii. You notice the one where the waves are hitting it, that's where the wind is hitting, that is the windward side of the island. On the other side of the island, the wind is blowing from the land out to the water. The waves aren't nearly as big, it's not nearly as rocky and as rough. You have a lot more beaches and sand on that side of the island. So that's the windward side, and that's the leeward side. Note the differences. So the question becomes, which side of an island would you be more likely to find hotels and tourists? Well, think about it. You take your family to a nice tropical island, whether it's Hawaii or in the Caribbean, and you want to go to the beach. This would be the side of the island. The leeward side is the side you're going to find all the nice white sandy beaches. The other side is going to be rougher and rockier. The waves are going to be stronger, so not as big a vacation destination. So that's the end of this presentation. Make sure to show me what you have learned from this. Prove to me that you have learned something from this presentation in order to get your Dunstamp and credit for today.